So we'll be doing little of congruent triangles, polynomials, and lines and angles today. Okay, look at this question. In triangle ABC, D is the midpoint of BC. In triangle ABC, D is the midpoint of BC. All right. If DL is perpendicular to AB, DL is perpendicular to AB. Please look at the figure as I read it. If DL is perpendicular to AB and DM is perpendicular to AC, stop that. Holy. Such that DL is equal to DM, such that DL is equal to DM. All right, it's marked in the figure. Prove that AB is equal to AC. Prove that AB is equal to AC, meaning prove that the triangle is isosceles. Okay, we'll just see the information given again. In triangle ABC, what we have to prove is AB equal to AC. All right, we are given that DL. What is D? D is the midpoint of BC. Okay, you need to have all the information given in your mind. What is D? D is the midpoint of BC. And from D, we have DL perpendicular to the side AB. And from the same point D, we have DM perpendicular to the side AC. Given all this, you need to show that ABC is an isosceles triangle with AB equal to AC. All right? Okay. So to prove that AB is equal to AC, it's okay to prove that angle B is equal to angle C, right? If you prove that angle B is equal to angle C in a triangle, when these two angles are equal, the side opposite of this angle will be equal to the side opposite of this angle. When two angles are equal, the sides opposite of them are also equal. In a triangle, when two angles are equal, the sides opposite of the equal angles are also equal. So if you prove that angle B is equal to angle C, angle B is equal to angle C, angle B is of this triangle, and angle C is of this triangle. So take up these two triangles, show that they are congruent, and CPCT, you have this angle equal to this angle. So once you prove that angle B is equal to angle C, by the property, sides opposite to equal angles are equal, AC is equal to AB. Hence proof, right? Go through the proof. See here. So in triangle BDL, as I read, look at the figure. In triangle BDL and DMC, correct? I've numbered the angles. Okay. So angle 1 is equal to angle 2. See, the numbers will not be given. See, the question figure will be like this. This is the answer figure. So you need to draw the figure into your answer paper and mark angles to suit your convenience. So angle 1 is equal to angle 2 by 90 degrees, correct? It's given and it's each equal to 90 degrees, correct? Okay. Then BD is equal to DC. BD of the first, let me call this the first triangle. Let me call this one the first triangle and this one the second triangle. All right. So we have angle 1 of the first triangle equal to angle 2 of the second triangle, correct? 90 degrees. And we have BD, side BD of the first triangle equal to side DC of the second triangle because D is the midpoint of BC. Okay. And also we have DL of the first triangle. It's given, see, it's given here. DL is equal to DM. We have DL, side DL of the first triangle equal to side DM of the second triangle. So what does this make? This makes right angle opposite of that hypotenuse and some other side. Right angle. Angle 1 is 90 degrees, right angle. And we have mentioned about BD, right? See here. This is the right angle, this is the hypotenuse, and this is some other side. This is the right angle in the first triangle. This is the hypotenuse of the first triangle. This is some other side of the first triangle. In the same way, right angle of the second triangle, hypotenuse of the second triangle, and some other side of the second triangle. I have written it in that order. I have written it. See, we need to, look at the information and decide which rule we're going to use to show that these two triangles are congruent. It's not that you write and then decide. You decide first. With the information given to you, you decide, okay, this is going to be RHS. So then I write the equalities in the order R, H, and S. So RHS means the two triangles are congruent, right? So CPCT, we have angle 3 of the first triangle equal to angle 4 of the second triangle, right? So now angle 3 is equal to angle 4 CPCT. Therefore, which is the side opposite to angle 3? Opposite to angle 3, side AC. Opposite to angle 4? AB. Therefore, AC is equal to AB because sides opposite to equal angles are equal. Hence, good. Right? We're going to just discuss congruent triangles. I'll share these images. You can work it tomorrow. We'll work lines and angles and polynomials. This one we're just going to discuss. All right. Any questions with this one?
No, ma'am.
All right. Ready for the next one?
Yes, please.
Okay. So in the figure, AD is the median of triangle ABC. AD is the median. AD is the median. In the figure, AD is the median of triangle ABC. If BL and CM are perpendiculars, if BL and CM are perpendiculars drawn on AD and AD produced, prove that BL is equal to CM. BL equals CM. This one, BL equals CM. Okay. So what is AD? Median. And if AD is the median, D is the midpoint of BC. If AD is the median, then D is the midpoint of BC. Okay. Now, what is BL? BL is a perpendicular on the median AD. What is CM? CM is a perpendicular on the median AD produced. I'll just repeat that. In triangle ABC, line segment AD is the median on the side BC, which means D is the midpoint of BC. Okay. BL is a perpendicular on the median AD. CM is a perpendicular on the median AD produced. Given this, we need to prove that BL equals CM. BL equals CM. Okay, go through. Go through the proof, children. This is given and what we have to prove. This is the proof here. Please go through. I'll just come back in 2 minutes. All right. Okay, so again here to prove that BL is equal to CM, you just have to take up this triangle and this triangle, because BL is a side of triangle BLD or BDL. See this BL is a side of which triangle? This triangle BDL or BLD. So we have to take up that triangle. And then what about CM? CM is a side. CM is a side of the triangle CMD. This one, this triangle. So take up these two triangles. Show that they are congruent. So CPCT, you will get this. You can get this result. DL is equal to CM. Yeah. And everything is given because what do you mean by AD is the median on BC? D is the midpoint. D is the midpoint of BC because AD is the median. So D is the midpoint, which means BD of this triangle is equal to DC of this triangle. Correct? AD is the median. That means D is the midpoint of BC, which means BD of the first triangle is equal to DC of the second triangle. What else we have? We have median, then we have perpendiculars. This is 90 degrees, this is 90 degrees, right? So angle 1 is equal to, okay, I've numbered it here. So angle 1 is equal to angle 2, 90 degrees, vertically opposite angles are equal. This angle is equal to this angle. And then BD is equal to CD. So here we have two pairs of equal angles and one pair of equal sides. So that cannot make RHS. Though the triangles are right triangles, it cannot or it need not be RHS always. Because RHS is one right angle and equalities of two pairs of equal sides. So here it is, angle 1 is equal to angle 2, 90 degrees. Angle 3, this is 3 children, this is 3. This one, vertically opposite, this is 3. Angle 3 is equal to angle 4 here. Okay? Don't get confused, it's marked somewhere there. So here, this is angle 3. Angle 3 is equal to angle 4, vertically opposite angle 4. Correct? Angle 1 is equal to angle 2, 90 degrees given. 3 is equal to 4, vertically opposite angles are equal. And then BD of the first triangle is equal to CD of the second triangle. So this makes two angles and some other side. Two angles, see this angle, and some other side, DB. Because if it's included side, it should be LD. LD is included side. Similarly, for angle 2 and angle 4, the included side is MD. MD is included side. So it's not about LD and MD, it's about some other side, BD and CD. So AS. Two angles and some other side, correct? Sanjay? Yeah. Two angles and some other side. So see, everything is given. All information given. You just have to list the information and make sure that you pick information from the two triangles. You should not write an equality for the same triangle. You should say one angle of the first triangle is equal to another angle of the second triangle. One side of the first triangle is equal to another side of the second triangle. Okay, any doubts here?
No doubts, ma'am.
Yeah, once you show that the triangles are congruent, I've told you should write the names of the triangles in the correct order. You should name the triangles in the correct order. Yeah, ask me. Gayatri. Sorry? Angle A bisected with AD is the median. No, no. If AD is the median, AD need not be the bisector of angle A. No, no. They are two different things. They are two different things. If, okay, if AD is the median on BC, AD need not bisect the vertical angle A. This angle need not be equal to this angle. All right? Okay. So the two triangles are congruent, and CPC, you should name the triangles in the correct order. And in CPCT, you have here LB is equal to MC, or BL is equal to CM. BL is equal to CS, correct? Yes, miss. And naming the triangles also is not difficult. See, if you say LDB, that is this angle, angle 1, then angle 3, and B. So in the other triangle, it's going to be MDC. Match the angles. If it is L of the first triangle is equal to M of the second triangle, right? And then D, why? Because vertically opposite angles are equal. So see here, D. Then the third vertex, B and C. I think this is from NCRT. Okay, you can go through this anyways. Okay. So ABC is an isosceles triangle with AB equal to AC. The bisectors of angle B and angle C meet AC and AB in D and E. Okay. So BD is the bisector of angle B. CE is the bisector of angle C. Bisectors of angles meaning, suppose I number this 1 and 2. Angle 1 is equal to angle 2. Angle 3 is equal to angle 4. Because the angle is bisected. Divided into two equal angles. Okay. So AB is equal to AC, which also means this angle, the whole of angle B is equal to whole of angle C. Correct? Because in a triangle, when two sides are equal, when this side is equal to this side, that means this angle is equal to this angle, right? When two sides are equal, the angles opposite of them are also equal. Now, this is the bisector of this angle, and this is the bisector of this angle. As it is, angle B is equal to angle C. Why? Because the two sides are equal, so the angles are also equal. So half of angle B will be equal to half of angle C. Okay, we'll come to that. So we have all this, is what I'm trying to say. With AB equal to AC, it means angle B is equal to angle C. It also means half of angle B will be equal to half of angle C. Okay. The bisectors of angle B and angle C meet AC and AB in B and E respectively. Prove that BD is equal to CE. BD is equal to CE. BD equals CE. So BD is a part of which triangle? Is a side of which triangle? BD. You can say BDC, or you can say ABD also. You can say anything. BD, this BD is a side of which triangle? You can say BD is a side of triangle ABD. Or you can say BDC. Similarly, CE is a side of triangle AEC or BCD. BC, oh, EC, yeah, BCE. BCE. So for BD, you can take up, see, you look at, you see the triangle with only BD, then you'll understand better. This BD, no? This is BD, right? So which are the two triangles that have BD? ABD, BDC. So then triangle ABC, this is CE. So which are the two triangles that have CE? ACE or AEC, and then BCE. Yes or no? So take up these two triangles, show that they are congruent, and hence you can show that BD is equal to CE. Or take up these two triangles. Take up the triangles marked 1. Show that they are congruent. So CPCT, you will get the result BD equals CE. Or take up the triangles marked 2. Show that they are congruent. CPCT, you will get the result BD is equal to CE. You cannot take this triangle and this triangle. You can take these two triangles, show that they are congruent. CPCT, you will get BD is equal to CE. Or you can take up these two triangles, show that they are congruent. CPCT will get BD equals C. Correct? Okay. Yeah. So here in this proof, we can see BDC and BEC, BDC this one, and BEC this one. These two triangles. So what are the equalities you can list? BC is a common side. BC is a common side. Then AC is equal to AB. AC is equal to AB. Why? Which are the two triangles you have taken up? No. Are we talking about these two triangles? BDC, BDC, this one and this one? Now, which are the two triangles you are talking about, Rahul? ABD, the top triangles, is it? Okay, okay. Let me just finish with the bottom triangles, these two triangles. So in this triangle and in this triangle, BC is the common side, correct? And then angle C of this triangle is equal to angle B of this triangle. See, please draw the triangle separately like this. Otherwise, it's difficult to understand. See, like this. And we are looking at these two triangles. We are looking at these two triangles. Okay, is that clear? Now, BC is equal to BC, common side, correct? Then angle C of this triangle is equal to angle B of this triangle. Why? Because in triangle ABC, AB is equal to AC. Therefore, the angle opposite to AB, angle C, is equal to the angle opposite to AC, which is angle B. So these two angles are equal. Because AB is equal to AC, the angles opposite of these two sides are equal. So angle B is equal to angle C. So angle B of this triangle is equal to angle C of this triangle, or angle C of this triangle is equal to angle B of this triangle. Correct? Now coming to this angle and this angle. So angle B is equal to angle C, right? So what is this one? It's half of angle B. And what is this? It's half of angle C. Why? Because they are bisectors. BD is the bisector of angle B and CE is the bisector of angle C. The two angles are bisected, divided into two equal angles. All right. So what you see here, what you see here is half of angle B. What you see here is half of angle C. So we know that angle B is equal to angle C. When two things are equal, their halves are also equal. So we know that angle B is equal to angle C. So half of angle B will be equal to half of angle C. And that's what is this. Angle half of angle B is equal to half of angle C. So this angle is equal to this angle. This angle is equal to this angle. And this is the common side. So it is ASA. Two angles and the included side. ASA congruence criterion, the two triangles are congruent. We'll see it again. Do we understand this property that in a triangle, when two sides are equal, the angle opposite to this side is this angle. The angle opposite to this side is this angle. Since this side is equal to this side, the angle opposite to this side, angle C, will be equal to the angle opposite to this side, angle B. So since AB is equal to AC, angle B is equal to angle C. Now come here. BC, the easiest thing we can write is BC is equal to BC common side. Okay, very easy. Then angle C is equal to angle B. We just understood that. Angle B is equal to angle C because isosceles triangle. Then this angle and this angle. You should write angle B is equal to angle C. Half of angle B is equal to half of angle C. This is half of angle B. This is half of angle C. They're equal. You can name it like DBC is equal to ECB. And so what's the rule? ASA. So list the equalities in that order. So see here, I think I don't have to repeat. So you can see here, and this is the first one. Then this is A, this is S, and this is A. Correct? Yes, miss. Yeah, look at this one. Okay. So here, x is equal to y. So which means this angle, x is equal to y, meaning this angle, x is equal to this angle y, x is equal to y, AB is equal to CB, AB is equal to CB, okay? Prove that AE is equal to CD. Okay. So since you need to take triangles that include the information given as well as include the line segments or angles which have to be proved are equal. Correct? The criteria in selecting the triangles. You must take two triangles that include the information given. You're taking some two triangles, but information is given about something which is not a part of those two triangles. Then what will you do with the information given? So you need to select two triangles which include the information given to you. And also it should include the sides or angles that have to be proved are equal. Okay. So when we take up this triangle, A, B, this triangle. What do you call this? ABE. ABE. So we are taking this triangle ABE includes AB, right? Yes, yes. And it also includes AE. When you take up the triangle ABE, it includes AB and it also includes AE. Okay, that's one triangle. The other triangle should include CB and CD. CB and CD. So CB and CD meaning CB and CD. So this one, this triangle, correct? So you need to take up the triangles ABE and CBD. One triangle should include these two sides, children. The other triangle should have these two sides. This is given. This is to be proved. So when you take up the triangle AEB, 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 in this triangle, AB, AE. Yeah, you can see here the side AB, side AE. Okay. Sides. Then in this triangle CDB, CDB in this triangle, we have the side CB and CD. CB is here, side CB is here, and CD is here. Okay. So in these two triangles, now it's given that angle X is equal to angle Y. But angle X and Y, they are not a part of any of the two triangles we've taken up, right? If X is equal to Y, if supposing this 60 degrees, this is 60 degrees, then how much is this one? 120, right? How much is this? 120, correct? So that means if X is equal, so 60 is equal to 60, so 180 minus 60 is equal to 180 minus 60. If X is equal to Y, 180 minus X will be equal to 180 minus Y. When two things are equal, these two things are equal. So if you subtract these two quantities from 180, 180 minus X, 180 minus Y, they'll also be equal. Because like if 60, 60, then 180 minus 60 will be equal to 180 minus 60. 120 equals 120. Okay. So X is equal to Y. 180 minus X is equal to 180 minus Y, which means angle 2. I've marked that 180 minus X is this angle, right? From 180, if you subtract X, it is angle 2. And from 180, if you subtract angle Y, it's angle 1. The result is angle 1. See, or in other words, X plus 2 is what? X plus 2, X plus angle 2 is equal to 180, right? X plus angle 2 is 180. So what is angle 2? 180 minus x. Angle 1 plus y is equal to 180. So angle 1 is equal to 180 minus y. Okay, that's what it is. X plus angle 2 is 180. So what is angle 2? 180 minus x. Angle 1 plus y is equal to 180, which means angle 1 is 180 minus y. That's what we have here. X is equal to y. 180 minus x is equal to 180 minus y. And what is 180 minus x? Angle 2. What is 180 minus y? Angle 1. Instead of 180 minus x, I've written the answer. What is 180 minus x? Angle 2. What is 180 minus y? It's angle 1. Correct? Okay. So where is 2? Where is the?
I don't understand one part.
Sorry?
How do you assume that angle 2 is 180 minus x and angle 1 is 180 minus y?
Okay, 1 minute. Now, is this a straight line? BA?
Yes, ma'am.
So the sum of these two angles is equal to 180? Linear pair?
Yes, ma'am.
Okay.
Yes, ma'am.
So which means x plus angle 2 is equal to 1 x degree. This is angle, right? X degrees plus angle 2 is equal to 180. Is this correct?
Yes, ma'am.
Okay. So what is angle 2? When you transpose, you'll get 180 minus x, correct?
Yes, ma'am.
Okay. So here below we have angle 1 plus y is equal to 180 for the same reason, linear pair. So what is angle 1 then?
180 minus y.
180 minus 1. So now come back here. X is equal to y, which means 180 minus x will be equal to 180 minus y. 180 minus x is nothing but 180 minus x is nothing but angle 2.
Understood, ma'am. Thank you.
And 180 minus y, 180 minus y is angle 1. So it's like the angle 2 and x, they are friends. Okay, together they have 180 degrees. Together they have 180. So total is 180. From 180, if you subtract x, it is 2. And from 180, if you subtract 2, it is x. Because together they have 180. Angle 2 and x put together is 180. These two together is 180. So 180 minus angle 2 is x degrees. 180 minus x is angle 2. Similarly, 180 minus angle 1 is y degrees. 180 minus y degrees is angle 1. Okay. So that becomes a part of which angle? Angle 2 is a part of this triangle. The part of this triangle, BDC. Correct? And angle 1 is of this triangle. Angle 1 is of this triangle. BEA. BEA. 2 is of BDC. BDC, this triangle. Angle 2 is of this triangle. Angle 1 is of this triangle. Hold on, Gayatri. One second. Okay. And then you have angle 3 common to both the triangles. Angle 3 common to both the triangles. We also have AB equal to CB. AB of one triangle is equal to CB of the other triangle. So what are the equalities we have? AB is equal to CB, directly we have. Angle 3 is common to both the triangles, also we have. So just one other thing we found. X is equal to y. 180 minus x is equal to 180 minus y. So 180 minus x is angle 2. 180 minus y is angle 1. Common angle, and this is given to you. How to name the triangle? Do we remember that? You remember? Okay. So this triangle, see, I've written AEB, AEB, AEB. If you name one triangle in any way you want, AEB. So now match the angles. AE is angle 1, right? So it should be D in the second triangle, D. Where there is E, there should be D. E is in the second place, so D in the second place. And angle 3 is a common angle. Angle 3, which is B. So B, it is B. Then the third vertex, C. So the two triangles are congruent, and CPCT, we have AE equals AD. AE, you can see here, AE equals, sorry, A equals CD. AAS will. Correct? Yes. Yeah. Have a look at this one. Correct? Yeah. So again, in these two triangles, angle A is equal to angle E, 90 degrees given. And then we have two equalities given AB equals DE, AB equals DE, and BF is equal to CD. Now BF is equal to CD is not you cannot use that, right? BF is equal to CD. BF and CD, they're not line segments or sides of any triangles. You cannot use that. But to BF, if you add a CF, what will you get? Let's just take this portion CF. CF. To BF, if you add CF, what do you get? BC. Similarly to DC, this is BF, this is CD. To CD, if you add the same thing CF, what will you get? CD and CF? DF or FD, right? So to this equality, you should add CF to both the sides. You should add CF to both the sides to this equality. Because this one, BF is equal to CD, you cannot use because BF and CD, they're not sides of any two triangles. So you need to add some, another line segment to both of it so that it forms a complete side in the two triangles. Okay, so that's what we have done here. BF is equal to CD given. To this equality, we add CF to both the sides. We add CF to both the sides. This is given, we add CF to both the sides. So now BF plus CF. BF plus CF is BC. And then CD plus CF is FD. So now these two are sides of the two triangles. You can see BC is a side of the top triangle and DF is a side of the bottom triangle. And then we are also given that AB is equal to DE. AB of the top triangle is equal to DE of the bottom triangle. So AB of the top triangle equal to DE of the bottom triangle. And then we have this equality. This BC is equal to DF by adding BC is equal to DF, which we got by adding CF to both the sides. And we also have 90 degrees. So it makes right angle, hypotenuse, some other side. Because this 90 degrees, then this side is equal to this side. So 90 degrees here. In the top triangle, opposite to 90 degrees is BC. In the bottom triangle, opposite to 90 degrees is DF. In the top triangle, opposite to 90 degrees is the side, which is, what's the name of the top triangle? ABC, right? ABC, where A is 90 degrees. So which is the side opposite to angle A? BC. In the top triangle. This is 90 degrees. So opposite that is BC. And some other side AB. In the bottom triangle, this is the bottom triangle, this is 90 degrees. Opposite to 90 degrees is DF. And some other side, DE. So RHS rule, the triangle is congruent. This is NCRT. Just go through this. This is NCRT. If it's simple, you will take the last bench. Okay. We have done this proof earlier in the class. Yeah.
Um,
Okay, so it's given AB is equal to AC is given to us. So that means in this triangle, it's given that AB is equal to AC. So that means angle 1 is equal to angle 2. And in this triangle, it's given that AD is equal to AC in this triangle. In this triangle, it's given that AD is equal to AC. This triangle. Okay. AD is equal to AC is not given directly. It's given AD is equal to AB. It's given that AD is equal to AB. But if AD is equal to AB, it means AD is equal to AC, right? Because AB and AB and AC are equal. Let me come from here. See here, I've written something here. This is given, this is given. This is given, this is given. When you compare these two, because AB is equal to AC and AB is equal to AD, see, it's given. AB, AC, AB, AD is given. So when you compare these two, you have all the three equal, like A is equal to B and A is equal to C. That means A is equal to B is equal to C. All the three are equal. It's common, no? AB is common. So AB is equal to AC and the same AB is equal to AD. That means all the three are equal. So I've taken up AB is equal in this triangle. In this triangle, you should write AB is equal to AC. And then in this triangle, in triangle ADC, what are the sides you have? AC and AD, no? So write AC is equal to AD. And using the isosceles triangle property, these two angles are equal. Angle 4 is equal to angle 3. Opposite of this side is this angle. Opposite of this side is this angle. Right? Using the isosceles triangle property, when two sides are equal, the angles opposite of them are also equal. So in this triangle, this side is equal to this side. So the angle opposite of this side, this angle, is equal to the angle opposite of this side, this angle. So this is angle 4, this is angle 3. So take up triangle, I'm repeating, take up this triangle ABC, mention the two equal sides. Therefore, these two angles are equal. Then take up the other triangle ADC, mention the equal sides. AD is equal to AC. Mention the equal sides. So these two angles are equal. Have these results. Now in the whole triangle, in this whole triangle, angle 2 plus angle 1 plus angle 3. See, this is angle 2. This is 1 and 3. And this one is angle 4. The sum of these angles is 180, right? Because in a triangle, the sum of all the angles is 180. This BCD is one triangle. BCD is one triangle. In BCD, I have marked this angle 2. This one I've marked angle 1 and 3. This one is 4. So look at the whole triangle BCD. So angle 2 plus this angle, which is 1 plus 3. There's only one angle, but it's 1 and 3 together. So angle 2 plus angle 1 plus 3 plus angle 4. So 2, 1 plus 3 and angle 4 is equal to 180. You'll have to prove that BCD is 90. BCD is 90 meaning angle 1 plus angle 3 is 90. 1 plus 3 is 90. So you have 1, you have 3. You don't want 2 and 4. You don't want 2 and 4. So what is angle 2? Angle 2 is angle 1. You don't want 4. 4 is 3. 2 is equal to 1. 4 is equal to 3. 2 is equal to 1. 4 is equal to 3. Because you want only 1 and 3. 1 and 3. So replace. So you have twice of angle 1 plus 3. Because this is twice of angle 1 plus twice of angle 3 is equal to 180. So twice of angle 2 common. Twice of angle 1 plus 3 is 180. 2 comes to the other side for division. 180 by 2, 90. 1 plus 3 is BCD. Therefore, BCD is 90 degrees. Yeah, go to this one. Okay. So in the figure, the bisectors of angle B and angle C meet at I. The bisectors of angle B and angle C. So that means, what is it, mark 7 and 8, no? Angle 7 is equal to angle 8 because BI is a bisector of angle B. And angle 3 is equal to angle 4 because CI is the bisector of angle C. CI is the bisector of angle C. BI is the bisector of angle B. Okay. The bisectors of angle B and C meet at I. If IP is perpendicular to BC, IP is perpendicular to BC, IQ perpendicular to CA, and IR perpendicular to AB. Prove that IP equals IQ is equal to IR. IQ is equal to, sorry, IP, right? Sorry. So that IP is equal to IQ is equal to IR. Prove that these three are equal. Okay, and also prove that IA, this one, bisects angle A. We only know that IB bisects angle B, IC bisects angle C. We'll have to prove that IA bisects angle A. See the line segments IA, IB, IC. Okay. IA or AI, you should prove bisects angle A. BI already bisects angle B. CI bisects angle C. BI bisects angle B, CI bisects angle C. You should prove that AI bisects angle A. That's the second thing you'll have to prove. The first thing is you should prove that IP is equal to IQ is equal to IR. So to prove this result, you should, supposing you call this like A, B, and C, you must prove that A is equal to B and B is equal to C. So A, B, C all are equal. Like you must take up two triangles, show that IP is equal to IQ. And another two triangles show that like you can show that IQ is equal to IR, or you can show that IP is equal to IR. What have we done? Yeah, IP is equal to IR. So all the three are equal. See, it's like this. If suppose A is equal to B and A is equal to C, then A is equal to B is equal to C. Or supposing B is equal to A and B is equal to C, then also A, B, C all are equal. Supposing C is equal to A and C is equal to B. So if one thing is equal to two other things, then all the three are equal. If you take A, if it is equal to B and C, that means A, B, C all are equal. Or if you take B, B is equal to C, B is equal to A, that means A, B, C all the three are equal. Or if you take C, C is equal to A, C is equal to B, that means again all the three are equal. So to prove this result, you must take up this triangle and show that IR is equal to IP. IR is equal to IP. Then you must take up this triangle and show that IP is equal to IQ. You must take up this triangle and show that IR is equal to IP. IR is equal to IP. Then you must take up this triangle and show that this and this and show that IQ is equal to IP. So here we have proved that IR is equal to IP. IR is equal to IP. Here we have proved that IQ is equal to IP. IQ is equal to IP. So when you compare all the three, IP is equal to IQ is equal to IR. Yes or no? Tell me. In these two triangles, what will you prove? IP is equal to IR. These two triangles, IP is equal to IQ. IP is equal to IQ. So when you compare these two results, because IP is common now to both. IP is equal to IR, IP is equal to IQ. That means all the three, IP, IQ, IR, all the three are equal. That's the first one. Then you should show that IA bisects angle A. That means you must show that angle 11 is equal to angle 12. 11 is equal to 12. So for that you should take up this triangle and this triangle. IAR, IAQ. IAR and IAQ. Show that they are congruent. Show that those two triangles are congruent. CPCT you will have 11 is equal to 12. Yeah. So I have not explained the proof. Just go through. I'll ask you the equalities. Always draw the figures to your answer paper and number the angles like this. It's easy for the teacher to correct, easy for you to write also. Okay. Any instruction that you should not mark angles like this and that you should write the names. All right. Yeah. It's always easy to mark like this. Okay. So when you take up these two triangles, let me see here. When you take up these two triangles, angle 7 is equal to angle 8. Why? Because BI bisects angle B. Okay. And then it's given, what do you mean by IP perpendicular? IP is perpendicular meaning 90 degrees, right? IP perpendicular to BC. IP is perpendicular to BC. So if it's 90 here, it's 90 here also. Similarly, here 90 means 90 here. 90 here, 90 here. IP is perpendicular to BC, IQ is perpendicular to AC, and IR is perpendicular to AB. Okay. So in these two triangles, angle 7 is equal to angle 8 because BI bisects angle B. Angle 6 is equal to angle 5, 90 degrees given, and BI is the common side. BI is the common side. Where have I done that? Here. Then when you take up these two triangles, this triangle and this triangle, similar information. Angle 3 is equal to angle 4 because CI bisects angle C, and angle 2 is equal to angle 1, right? 90 degrees. And common side, CI is the common side. Correct? So when you show that these two triangles are congruent, CPCT, you should write IR is equal to IP. Here, when you show that these two triangles are congruent, you must write IP is equal to IQ. IP is equal to IQ. So IP is equal to IQ, IR is equal to IP. CPCT from the congruency of the two sets of triangles. So you can see IP is common. IP is common. See, you will get IP is equal to IR from one and IP is equal to IQ in the other. So IP is common, no? So that means all the three are equal. IP, IQ, IR, all the three are equal. All right? That proves the first part. And then for the second one, you need to take up these two triangles. And here you should show that angle 11 is equal to angle 12. You cannot write angle 11 is equal to 12 because IA bisects angle A. No, you should prove that IA bisects angle A. In here and here, we had BI bisects angle B, CI bisects angle C. But here you'll have to show that AI bisects angle A. So angle 11 is equal to angle 12 is not given. That's what you have to prove. You must prove that angle 11 is equal to angle 12. Correct? Okay. So in these two triangles, angle 9 in this triangle and in this triangle, 9 of this triangle is equal to 10 of this triangle. Then AI is the common side. And you can take results which you have proved earlier. So we have proved that IR is equal to IQ, right? All the three are equal. See here, IR is equal to IQ. We've proved. IR is equal to IQ. We've already proved here. So take up these two triangles. This is the common side. And we've already proved in one that IR is equal to IQ. And then angle 9 is equal to angle 10, 90 degrees. So this one is right angle, common hypotenuse and some side. Right angle, common hypotenuse and side IR. In the other triangle, right angle, common hypotenuse and side IQ. RHS rule, the two triangles are congruent. Oh, is it on the next slide? Oh, no. Oh, sure. So these two triangles, I repeat, angle 9 is equal to angle 10, that is R. Then AI is equal to AI, common hypotenuse, that's H. And some other side, IR is equal to IQ. That's not given, but we have proved here IR is equal to IQ. So RHS rule, the two triangles are congruent. CPCT, angle 11 is equal to angle 12. If angle 11 is equal to angle 12, it means AI bisects angle A. This one. Yeah, go through this one, children. I'll just come back. I'll just tell you one thing that in this figure, this one is a combination of an equilateral triangle and a square. So in an equilateral triangle, all the three sides are equal. In a square, all the four sides are equal. Now this triangle and square, they share a side. They have a common side. So that means all the sides are equal. In an equilateral triangle, all three sides are equal. In a square, all the four sides are equal. But the triangle and the square, they have a common side. That means all the sides are equal. That is the side of the equilateral triangle and the side of the square. They have the same length. So QR is the side which is common to the triangle and to the square. QR is the side common to the triangle and the square. So say QR is 10 centimeters. So what do you say about PQ 10? PR 10. Why? Because equilateral triangle, all sides are equal. What do you say about the side of the square? QR is 10. So everywhere it's 10 because in a square all sides are equal. So all the line segments. So this you can use for like writing equalities of sides. So like if you take up this triangle and this triangle, this triangle and this triangle. Yeah, I hope you understand. Yeah. Just come back, go through. Okay. So we need to show that PT is equal to PS. PT is equal to PS. So we need to take up the triangles PQT and PRS. Okay, so in triangle PQT and PRS, PQ of this triangle is equal to PR of this triangle, correct? Take up the triangle PQT. So don't see this line in the middle. Don't consider this one. This is not there. This one is not there. So PQT like this. This is one triangle. Correct? And on the other side, we have like this, another triangle like this. PQT, PRS. So PQ is equal to PR because equilateral triangle, all sides are equal. Then QT is equal to RS, side of the square. And then angle 1 is 60 degrees. Angle 3 is 90 degrees. Angle 1 is 60 because equilateral triangle. Angle 3 is 90 because square. So what is angle 1 plus 3? Or you don't have to find the angle. Okay, I have found the angle. Okay. You need not find the angle also. You can just write angle 1 is equal to angle 2. Angle 3 is equal to angle 4. So angle 1 plus 3 is equal to angle 2 plus 4. Angle 1 plus 3 is equal to 2 plus 4, which means angle PQT is equal to, I have found the angles here. You can do it either ways. So you can also do it like this. You can write angle 1 is equal to angle 2. Angle 3 is equal to angle 4. So when you add, you get angle 1 plus 3. Now, what is angle 1 plus 3? PQT. Angle PQT is equal to 2 plus 4, which is PRS. PRS. You don't have to find the angle also. But you can also find the angles like this. I found the angles. Okay. So if you find the magnitude of the angles, then you'll get 90 plus 60, 150, 90 plus 60, 150. That makes SA, side, angle, side. SAS means the two triangles are congruent. So CPCT, you will have PT equal to PS. PT is equal to PS, CPCT. So first part is over. Next, you need to prove that PSR is 15 degrees. PSR, this angle. This one is 15 degrees. Now, as we understood a little earlier, that PR is equal to RS, right?
Yes, miss.
PR is equal to RS. So in this triangle, PRS, PR is equal to RS. That means it's an isosceles triangle. So if these two sides are equal, then this angle will be equal to this angle. Now, how much is this angle? 150. What is 180 minus 150? 30. 30. So these two angles will share it equally. So 30 by 2, 15 degrees. In triangle PRS, see, this is the triangle PRS. This is the triangle PRS, in which we know this is 150 degrees. This is 150 degrees, this one. This side is equal to this side. So that means this angle is equal to this angle. So 180 minus 150 is 30. Since these two angles are equal, they'll share the angle equally, 30 by 2, 15 degrees. That's what is working here. So after showing that PT is equal to PS by congruency, you can go through this. That's what I've mentioned here. I've taken up the common side. So how do you present here? QR, that is, we need to show that PR is equal to RS, right? See, sometimes, even if you know, you need to also know how to express, right? So QR is the common side. See, first plan, you need to show that PR is equal to RS, correct? PR is equal to RS. So use a mediator. That mediator should be the common side, QR. So you say, listen carefully, you need to show that PR is equal to RS. PR is equal to RS. Okay. PR is equal to RS. So take up somebody, a neutral person, like somebody common to both. So QR. QR. So is this correct? QR is equal to PR. Is it correct? Yeah. QR is equal to PR. Correct. Then here QR is equal to RS. Is that correct? QR is equal to RS. Yeah, square. First is about the triangle. Second is about the square. QR is equal to PRS of the triangle. QR is equal to RS of the square. So see, we have taken QR, a common side to the two figures. So QR is equal to PR, QR is equal to RS. So that means PR is equal to RS. PR is equal to RS. And where do we have these two line segments, PR and RS? PR and RS in the triangle PRS. In the triangle PRS. So in this triangle PRS, this side is equal to this side. So this angle is equal to this angle. Then angle sum property. All right? Yes. I marked this angle 5 and this one angle 6. So angle 5 is equal to angle 6. 6 plus 5 plus angle PRS is 180. PRS is 150 degrees. And 5 and 6 are equal angles. So instead of 5, you can say 6. So twice 6 is 30. 6 is equal to 15 degrees. Which means PSR is 15 degrees. This is important. We'll do this one first. Go through this. Done? Ready? Okay. All of you write this proof without seeing. Take down the so given, it's all mentioned there. Given proof, and you have the diagram, right? Yeah. Write the proof. You need to write the proof. for this one. Did you all go through the proof? You want to see it again? I can show you. You want it for some time? You want to have a look at the proof? Yes. No? Okay, those who want to have a look can just go through the proof and then write. Okay, let me present it. You can just practice. Okay. Okay, if you like, you can understand this proof backwards, so that you understand why we get the intermediate results, why you have to prove the intermediate results. See, it's like this, to show that the whole triangle ABC is congruent to the whole triangle NML. What is that we have? We know that all these are perpendiculars. No? Okay, AL is equal to CN. AL is equal to CN. And then BL is equal to CM. Where is BL? BL. This is equal to CM. Anything else? Okay. Yeah. ABC. LMN. Oh, yeah. Okay, so to show that the whole triangle, this whole triangle ABC is congruent to the whole triangle, you can do this in two ways. I have only one of it here. You can either use the SSS rule or the SAS rule. Okay, so the proof will go like this. See, first take up this triangle and this triangle. Okay, take up these two triangles. Can I have your attention? Take up this triangle and this triangle and show that they are congruent. How congruent? Because this side is equal to this side given. This side equal to this side given. 90, 90 given. SA is congruent. CPCT, this one is equal to this one. So we've got one information now. We've got one information. AB of triangle ABC is equal to MN of triangle MNL. We got one equality we got. Now take up this triangle and this triangle and show that they are congruent. Okay. So here we have LC is the common side. LC is the common side. Then MN of this triangle is equal to BL of this triangle. And then 90 degrees. 90 degrees. So again SAS, because this side, 90 degrees, 90 degrees, common side. Right? So again, SA, these two triangles, CPCT will have ML is equal to BC. BC of this triangle is equal to ML of this triangle. So that's what, this is enough. This is enough. Just 1 minute. Now the third equality will be AL is equal to CN. We already know that. We know that AL is equal to CN. We'll add LC to both the sides. We'll add LC to both the sides. What is AL plus LC? AC is equal to what is CN plus LC? CN plus LC LN. So this is the third pair of equal sides. AC of the first triangle ABC is equal to LN of the second triangle MLN. All right? Yes. So the two triangles are congruent by SS. Yeah. So you can also, write this one. This angle equal to this angle. CPCT, you can write angle 1 is equal to angle 2. Again, CPCT, you can write like when you took up this triangle equal to this triangle, you can also write angle 1 is equal to angle 2 CPCT. Then when, oh, no, not these two triangles, sorry. When you take up these two triangles, okay, CPCT, you should also write this one is equal to this one. When you take up this triangle is equal to this triangle, also write, you will write this one equal to this one by CPCT. Also write this angle is equal to this angle. Then when you show that these two triangles are congruent, you will be writing this side is equal to this side. You also write this angle is equal to this angle. Now, angle 1 is equal to angle 2 CPCT. Angle 3 is equal to angle 4 CPCT. So angle 1 plus angle 3 is equal to angle 2 plus angle 4. What is 1 plus 3? Angle ABC. Equal to 2 plus 4 is angle LMN. So this way you can use SAS also, because you will write AB is equal to MN. Then angle ABC is equal to angle LMN. And then you will write BC equals ML. So this will make SAS. Yeah, I think now you can just do it by yourself. I'm just coming. Finished? Yes. So how does the proof go? We need to take up these two triangles, show that they are congruent, right? So this side equal to this side, then this angle equal to this angle, and this side equal to this side, all given. What is the rule? SA. For this one, it is SAS. Okay, then we'll have to take up these two triangles. So again, same information you can use. This side equal to this side, then 90 degrees, 90 degrees, and then, yeah. Is Gayatri? Yeah, common side. LC is equal to CL, common side. So the two triangles are congruent, CPCT. So from the first one, you will say CPCT, this side equal to this side. From the second one, you will say CPCT, this side is equal to this side. That's enough. If you have to use SSS, that's enough. Now take up the whole triangles ABC and NML. Two things we've already found. This one we've proved in one, this one we've proved in two. Then for the third one, you should write AL is equal to CN given. And you should add LC, this portion to both the sides. LC should add to both the sides. So that will give you AC is equal to NN. SSS rule, the two times the congruent. Finish? Don't know how to work, huh? No way? What is? You don't know how to work? I go. You yourself? Sanjay? Yes. Yeah, what are the values of P and Q? Online children? Completed or still working?
Working, ma'am.
Okay. Okay, so see here, now wait. Okay. The first step is to give a name to the polynomial. So we'll say let f of x be equal to px cubed plus qx squared minus 5x plus 84. Okay, let f of x be equal to, don't use p of x because we have the letters p, q and x in the question already. So use letters other than these three. Okay, so f of x, x is the variable. Let f of x be equal to the given cubic polynomial. Now x minus 7 is a factor of f of x, correct? So x minus 7 is equal to 0, x is equal to 7. So that means f of 7 is equal to 0. F of 7 is equal to 0. See, this place is for the remainder. This place is for the remainder. What is the remainder? 0. Why is the remainder 0? Because x minus 7 is a factor. And if you divide a polynomial by its factor, the remainder will be 0. So f of 7 is equal to 0. Now, how do you work f of 7? In f of x, wherever there is x, you should use 7. So p into 7 cubed plus q into 7 squared minus 5 into 7 plus 84 is equal to 0. Get the equation for me. In the same way, Navid, what's the other equation? X minus 4 is a factor, right? X minus 4 is also a factor of f of x. Yeah. So x minus 4 will be x. X is equal to 4. X is equal to 4. So that means f of 4 is equal to? F of 4 will be 0. Why? Because it's a factor. 0. Yeah, it's a factor. So f of 4 is a 0 of the polynomial. So that means the value of the polynomial will be 0. See, if it's a factor, when you divide, what will be the remainder? 0. 0. That's what you should write here. Now work f of 4. How do you work this? P into 4 cubed plus q into 4 squared minus 5 into 4 plus 84 is equal to 0. Get me the two equations. P is 1, yes. Minus 8. Very good. Completely good. Take this. Yeah. Yes. Yeah, what's the equation you get for the first one, Sanjay? Did you get 343p plus 49q is equal to minus 49? Yes. Divide by 49 throughout. Did you do that? No. Dividing by 49 throughout. That's what you should do. Do you know that 7 squared is 49? Yes. Do you know that 7 cubed is 343? Then you can divide 343 and 49 by 49. Common. You can take out 40. Where the 0 Yeah, you can also take out 14 common. The equation. You can also take out. Yes, you can also put it. So this is 343p plus 49q. And this one is plus 49 is equal to 0. So as he said, you can even take out 49 common. So what will you get? 7p plus q plus 1 is equal to 0. Then this 49 will come for division here. 0 by 40. You can also take out 49 common. So 0 by 49 is 0. So you have 7p plus q is equal to minus 1. 0 by 49 is 0. Then plus 1 will come to the other side as minus 1. This is the first equation. Similarly here, 64p plus 16q. And what is this? 64, is it? Plus 64 is equal to 0. So what's common here? 16. So p plus q plus
14.
which is 4p.
61 divided by 16.
Yeah. Okay. 16 4 is 64. So 16 is common. Plus 4 is equal to 0. Then 0 by 16 is 0. So 4p plus q is equal to minus 4. The second equation. How do you solve these two equations? No, is this understood? 0 by 16 is 0. Then this plus 4 will come to the other side as minus 4. Now these are the two equations. How do you solve the two equations? How do we solve the two equations? 7p plus q is equal to minus 1 and 4p plus q is equal to minus 4. Write the equations one below the other. Now, can you cancel q and q? You cannot because q plus q is 2q. So you'll have to change the signs to go to the second equation. You finished, is it? Okay, so minus, minus and plus. Plus q minus q cancels. 3p is equal to 3, p is equal to 1. Substitute 7p plus q is equal to minus 1. 7 into minus 1 plus q is equal to minus 1. 7 plus q is equal to minus 1. Q is equal to minus 8. So the polynomial will be, the polynomial f of x is what? Px cube plus qx squared minus 5x plus 84. Now, use the values of p and q. So it will be 1x cubed or x cubed plus minus 8x squared minus 5x plus 84. Should use the values of p and q in f of x and frame the polynomial. Yeah. Completed all three?
Yes.
Next question. You completed the second one, Rahul? This one. Not question, answer.
No.
Okay. What are the two equations you've got? There were only ones? Sorry, only one. Okay. Okay. So children, what about you? Gary, started working this? How do you do this?
I just started. Just wrote down this.
Okay, so tell me, how will you go about the answer?
X is equal to 4. So x is equal to root of 4, x is equal to 2. You can find the value of x.
Yeah, continue. X is equal to root of 4.
X is equal to root of 4, so x is equal to 2.
Okay.
Then you substitute the value of x in the.
Okay, so you will get one equation. Then after that? Yeah, you're right, but not completely. So, okay. X squared minus 4 is equal to 0. X squared is equal to 4. X is equal to plus or minus square root of 4. X is equal to plus or minus 2. Yeah, because x square should be 4. Now, supposing x is minus 2. Minus 2 into minus 2 is plus 4, no? And plus 2 into plus 2 is also 4. So x square is equal to 4, meaning x is equal to plus or minus square root of 4. Yeah, x is equal to plus or minus 2. So we have two values for x. So like the earlier one, you can get two equations. Yeah. What is x squared minus 4? No, wait, it's a factor.
Yes.
It's a factor, right? Now we have two values for x, plus 2 minus 2. And x squared minus 4 is a factor. Yeah, so when you find f of, if you call this one f of x, if you find f of 2, what is f of 2 equal to? 0. And what is f of minus 2? 0. Because it's a factor. So the remainder will be 0. Please work. Tell me the equations from this.
A minus 0.
Yeah, what's the first equation? Rahul, you said something.
16A minus 2B.
Yeah, 16a minus 2b is equal to?
0.
I have 16a plus 2b is equal to 0.
That changes.
Hmm.
Because 16A plus 2B is equal to 0.
Yeah. You can take out 2 common, no? Or 8 common, sorry. 16A plus 2B, no? Yeah, so 2 common.
Then it will be 8A plus B.
B is equal to 0.
A is equal to 1.
Yeah.
B is equal to minus.
Sorry, B is equal to? Which answer do I have? 1 minute. B is equal to?
Minus.
And 8. Yeah, correct. Yeah, Gayatri, what are the equations? 8A. Next one, other equation. 8A minus 16B. No, tell me, what do you get here? 16A, 1 second, yeah. 16A. Plus. You written 8, is it? Then here. So what do you get? 16A plus 2B. Cancels, no? Minus 12 minus 4 plus 60 is equal to 0. You can take out 2 common. So you'll get 8A plus B is equal to 0. So 8A plus B is equal to 0 by 2, which is 0. It's the first equation. Yeah, you can put the whole. You got this, Yarni? Divitra? Oh, did you get this equation? What's the second equation? What do you get here? Is it minus 16 or plus 16? Plus 16. A. Then here, first you need to cube minus 2. What is minus 2 the whole cube? Minus 8. Minus 8 into plus 2, minus 16. Here also square minus 2. What's minus 2 the whole square? Plus 4. 4 into minus 3, minus 12. Minus 2b minus 4 is equal to 0. So 16a minus 2b minus 32 is equal to 0. So 16a, you can take out common. Yeah. So 2 you can take out common. Two is common. So we'll get 8a minus b minus 16 is equal to 0. Correct? 8a minus b minus 16 is 0. So 8a minus b is minus 16 is equal to 0 by 2, which is 0. 8a minus b is equal to 16. What's the second equation? 8a minus b.
8A minus B is equal to 16.
8a minus b is equal to 16. Yeah, 1 second. Yeah. So 8a plus b is equal to 0. 8a minus b is equal to 16. Should we change the signs? You don't have to change the sign because plus b minus b will get cancelled. 8a is 16a is equal to 16. So a is equal to 1. Then substitute a is equal to 1 and one of the two equations. So you'll get b is equal to minus 8. So a is 1, b is minus 8. What is the equation? Sorry, what's the polynomial? The polynomial f(p) of x or f of x, what do I use? F of x. What's a polynomial? It is ax to the power 4. What is A? 1. B? Minus 8. This is the polynomial, correct? Yeah. What are the factors?
X into x into x square minus 4 x plus 4 x not x plus 3.
Give me a book. Explain. I'll come to you. I'll come to you. I'll come to you. I'll come to you. I'll explain that. No, explain what your work is.
First I make the form of the equation.
No, but 4, this is not common. You should put the 4 outside. Minus 4 outside. No, here you should put the minus 4 outside. Correct. Then minus 8 also will come outside. Become minus, put the minus 8 outside. So it will become minus 4. Yeah, then what you do? X common. Then you got x square plus 2x. Then you split the middle term. Then what do you do with the minus 12 outside?
That way I interested.
Don't they use long division in your school? Long division. Yeah, yeah. What are we doing, Sanjay? You seem to be lost somewhere. In this question, we have to find the values of A and B. Found? Okay. Now we have framed the polynomial also. The question is to factorize it completely. What kind of a polynomial is it? It's a polynomial of degree 4. So it will have a maximum of 4 factors. It's biquadratic. Degree 4. So it's biquadratic. So it will have a maximum of 4 zeros or 4 factors. But 2 factors we already know, no? X square minus 4. X square minus 4 is a factor. What is x square minus 4? X plus 2 into x minus 2. A square minus b square is a plus b into a minus b. So x square minus 4 is already a factor. So divide. Divide this by x square minus 4, correct? When you divide, you will get a quadratic quotient and factorize that to find the remaining 2 factors. Do the division, all of you? Oh, minus. Yeah. Divide all of you. I don't think we can do lines and angles today. We'll try to do that in the next class. Got it? Okay, how do we do the long division? Divide the first term.
Can't find.
Oh, you can, but that's not a part of the syllabus. No? You have to show the long division. It's okay in your school? Okay. So x to the power 4 divided by x squared. You do the long division? No. In school, do they do the long division for factorizing? Yeah. So divide x to the power 4 by x squared. What do you get? X squared. Now multiply x squared with both the terms here. X squared into x squared, x to the power 4. X squared into minus 4, minus 4x squared. So minus 4x squared, you can write it under the x squared term. You can write it here, minus 4x squared like this. Write it under the x squared term. Okay? Now change the signs. Change the signs. Minus, plus. Okay? Cancels. This 2x cubed comes down. And here it will be plus x squared. Bring the remaining terms down. Is this correct? Yes. Now divide 2x cubed by x squared. What 2x cubed by x squared? What do you get? Plus 2x. So when you multiply plus 2x with x squared and minus 4, what do you get? Plus 2x into x squared plus 2x cubed. Plus 2x into minus 4 minus 8x. Write it under the x term. Yeah.
X minus 12 into x plus 2 into x minus 2 into x minus 3.
Okay. Then bring the remaining terms down. Now x squared minus x squared is 1. You know the long division procedure, Sanjay? Okay. You understood now? Once I started, you understood it. Very good. Okay. You should write it under the x squared term. Now you understood?
Yes.
Finished do it?
Yes, now understood.
Very good. Now you must factorize the quotient.
Okay. I was scared and overthinking that how should I get x cubed? But since you thought I understood it now.
Very good. Okay. Now you'll have to factorize the quotient to find the factors. So let me continue here. Okay. So what is f of x? F of x is equal to x squared minus 4 into x squared plus 2x plus 1. Why? Because dividend is equal to divisor into quotient. This is x plus 2 into x minus 2. Now here, Split the middle term. X squared plus x plus x. Huh? Oh. Hello? Gayatri? Take up from the last term because you were not well, is it? Take care. If you're not well, you always have the online class. Because I think the AC and everything is just triggering the common. Now we cannot do without the AC also. Or you can wear a mask and sit separately so that you are also comfortable. Okay? All of us, including me. Not cold, please get a mask and put some mask. And you can choose to sit separately so that you are also comfortable in like going coffee or comfortable and others also. Any questions? Your experience minus okay. No, actually, I'm not doing anything in detail. Just telling that in parts here and there because we've already done it. So beyond this fact, to clarify something, you could ask me. I have not explained everything in great detail. Just done some 30-40% of things. Division or whatever you have doubt, you can ask me. Your voice, no, how can you take the 4 square into the 3 minus 3 levels? How can you skip it? So when you multiply x square with x square, you get x power 4, and x square with minus 4, you get minus 4x square. Should write it under, if you have a like term, you should write it under that. You are considering that would be. That's what, you should not write it under the 2x cubed. You can write, but you should simplify minus 3x square and that 4x square. So it's better you write it under the x square term so that you can simplify it. Nothing. When you multiply, what you get? You get minus 8x square, right? You will see this is x cubed terms, but you have an x square term. Find the answer below that. Completed online children?
Yes, ma'am.
Okay. What's happening? Hold on. It's a factor. Yes, correct.
Next, we have to use long distance method.
Yeah. No, if your school is open, that you can. So teachers open, that you can.
It's very simple.
Yeah.
2x square plus x minus 15 is
2x squared plus x.
minus 15.
Very good. Yeah. Factorize that.
Okay, we split the little of 1x.
Yeah, 1 and what's the problem? 30 minus 30.
30.
No, multiply coefficient of x squared. That's 2. 2 into minus 15.
Thank you so much for the I am look at it's not. It's not. Yeah. X minus 2x minus. X minus 2x minus y and x plus 3. X minus 2 into 15x plus 1 minus into 2x minus 1
Into 2x?
minus 1. With x minus 2, 2x minus 5 and x plus 3.
Correct. You're right. So how do you show that it's a factor? X minus 2 is equal to 0, x is equal to 2, and you must find f of 2, right? Oh, 2. and you should find f of 2. Should find f of 2. And when you find f of 2, what should be the answer? It should be 0. If you get 0, therefore x minus 2 is a factor of f of x. That you will do. Then to factorize it, you should do the long division. To do the long division to factorize it. Let me do it quickly. 2x cubed minus 3x squared minus 17x plus 30. Divide by, you can look at the board, Rahul, since you're not sure about division. So what's the first term? 2x cubed divided by x, 2x squared. 2x squared into x, 2x cubed. 2x squared into minus 2, minus 4x squared. Change the signs. You have to change the signs. No choice. You have to change the signs. So you get x squared minus 17x plus 30. Now the next term will be plus x. X into x, x squared minus 2x. Change the signs. So you'll get 15x plus 30 minus 15x plus 30. Then minus 15. Minus 15 into x is minus 15x. Minus 15 minus 2 is plus 30. Change the signs. Cancel. Right? So now, what is f of x equal to? Divisor into quotient. Division algorithm. This is the dividend. This is the dividend. Is equal to divisor into quotient plus the remainder. Plus remainder is 0. So you don't have to write it. This is the division algorithm. F of x is equal to, where is f of x? Which is f of x? This one. This is f of x. Right? Dividend is equal to divisor x minus 2 into quotient. That's what we've written here. Now split the middle term. This one as it is. What is the sum? Plus 1. What's the product? 2 into minus 15. Minus 30. So that two numbers are 6 and minus 5. 6 and minus 5. 6 into minus 5 is minus 30. And 6 and minus 5 will give you plus 1. So 2x squared plus 6x minus 5x minus 15. So this x minus 2 as it is. 2 into 2x, sorry. Correct? With the middle term. What is the product? 2 into minus 15. Supposing it's minus x squared, the coefficient, the x squared term, supposing it's minus x squared, then supposing you have minus x squared plus x minus, or say plus 30, then the product will be minus 1 into plus 30, minus 30. Okay. We'll work this and wind up the session for today. Okay. I think it's remove your footwear here. Remove. Yeah. If A and B be the remainders, when Sorry?
And the 2x will be of the
Too far.
having the x, polynomial the x and polynomial. But where is the being? Written as 2a plus b is equal to 6.
There is A and B.
No, find
Finally,
a. There's one and the.
no, capital letter A and B are given that way. If A and B be the remainder. And find A is in the polynomial. Yeah, what is the answer?
Plus 2. Plus 2. I got the value as 8/7.
Yeah, no, I just checked if I've written the question correctly. Yeah. It's not, what do you say? 8/7. No. 1/2. No. Online children? See you. Yeah, just, okay, I'll send him answer. No.
What answer? Is what the answer?
The answer is 2/3. 2/3. No, we have to see how to do it. Now, when you divide p of x by x plus 1, what is the remainder? When you divide, no, mine. You can pack. I'll give. You will be sent home. Don't worry. I'll not retain you here. Don't get scared. Can I have your attention, all of you?
Yes.
See, what is given when p of x is divided by x plus 1, the remainder is what? Complete. When p of x is divided by x plus 1, what is the remainder? A. The remainder is A. So that means x plus 1 is equal to 0, x is equal to -1. So p of -1 is equal to A. I've told you this place is for the remainder. See, You're not able to concentrate. P of minus 1 is equal to A. This is the information given in the question. When P of X is divided by X plus 1, the remainder is A. See, if A and B be the remainders, when P of X and Q of X are divided by X plus 1 and X minus 2 respectively. So when P of X is divided by X plus 1, the remainder is cap letter A. When Q of X is divided by X minus 2, the remainder is cap letter B, is what is given. So this means X plus 1 is equal to 0, X is equal to minus 1, which means P of minus 1 is equal to the remainder A. So how do you work with this equation? P of minus 1. So it will be minus 1 the whole cube plus 2 into minus 1 the whole squared minus 5A into minus 1 minus 7 is equal to A. So you get A is equal to, since I have the answer, I'll just copy it from here, 5A minus 6. So you get A is equal to 5A minus 6. In the same way, when Q of X is divided by X minus 2, the remainder is B. X minus 2 is equal to 0, X is equal to 2. That means Q of 2 is equal to the remainder B. So in Q of X, wherever there is X, use 2, and you'll find B is equal to 4A minus 10. 4A minus 10. So we have expressions for A and B. A capital letter A is given by the expression 5A minus 6. Capital letter B is 4A minus 10. Now we have a condition given in the question. 2A plus B is equal to 6. We'll have to use these expressions in that condition. We are given that 2A plus B is equal to 6. So what is 2A? 2 into 5A minus 6 plus B plus 4A minus 10, correct? Is equal to 6. Do we understand that? Yes. We are given 2A plus B is equal to 6. 2 into the expression for A is 5A minus 6 plus B 4A minus 10 is equal to 6. So 10A minus 12 plus 4A minus 10 is equal to 6. So 14A minus 22 is equal to 6. 14A is equal to 28. Yeah, oh, no, I've written 2 by 3 in my paper and I've erased 3. I didn't notice that. So A is equal to 28 by 14, which is 2. Anybody got 2? Anybody else got 2? Just, I got number 2, miss. Okay. No. Let me just see. Can you see? Can you see the no one? You can't see. Miss, I can see this. Yeah, I just thought, yeah, it's 2 by 3, so I said no. Anyways, you said 8 by 7, right? Yeah, you said 2, is it? 4 by 2. Ah, okay. I'm safe. So A is 2. All right? Yes, 2. Yes, ma'am. Very good. Thank you. All right, children. So that's it for today's session. Online children, please stay back. That's it for today's session. Thank you so much. You may leave the call in some time.